In this module, we'll talk about high availability design. And previously, we had discussed high availability, but then now let's look at a little bit more detail on how this is actually done. So we'll look at various HA designs. In the first one, we're looking at an active standby server configuration for web servers in which you have a primary and a failover server. And this is an active standby configuration. All the traffic will go to the primary server, and if it fails, there's a heartbeat function. And if the primary server fails, then we shift over to the failover device or the standover device. The next one is an active server configuration, and what we see is that there are 5 sources of traffic, and here you have a load balancer. Now, the load balancer is directing the traffic or sending the traffic to 2 HTTP servers, 2 web servers, in a round-robin fashion. So you have traffic number 1, 3, and 5, or the packets 1, 3, and 5 would go to server 1, and packets 2 and 4, and then 6 would go to server number 2. In this diagram, we see the N+1 redundant configuration for high availability, which is neither standalone, it is not active standby, and it's not active either, but it's N+1. Usually N+1 is used for batteries, but it may also be used for other types of components. Sometimes it's used for RAID hard disks also. So here what we see is that we have batteries A, B, C, and D, 4 components. And then for all 4 of these are 4 separate modules of batteries, and we have just one backup, which is the N, which is one set to back up actually 4 of the battery banks. And here the N value is 4, and 1 is the set, which is the backup set. So you have N+1 or 4+1 configuration, and we have one backup for 4 battery banks. This is a diagram in which you see that there is an active standby Sun server cluster, and let's see how this is set up. So you have on the top, you see there is a Sun cluster 3.1. You have a network adapter failover, which is redundant in the Sun server, both the servers. There's a top server and there's a bottom server. And then you have an active node, the Solaris OS, and the global file system and volume management. And there's a heartbeat which is connecting both of these. It's a cluster interconnect. And then both of these Sun server devices are interconnected to RAID devices on the right side. So the active device is used first, and there's a complete replica. And if that fails, then we will shift over to the standby in the cluster. And there's a heartbeat function, and the system can tell if the active has failed. Now, this is high availability design for the network. And here we see that in the access layer, there are access devices which are dual homed or connected to a pair of distribution switches. And then you have the core devices, which are also two in number. And each core device is connected to each of the 6 distribution switch devices. So each of the core devices has actually 6 connections going out to the distribution switches and 1 connection going out to the other core device, which is next to it. And similarly, on the distribution layer and the access layer, we find that there's complete redundancy, and this is a high availability configuration. Now here we see a data center redundant configuration. And this is actually showing the primary and the secondary data center. On the left side, we see the primary. It has a full configuration, and there's additional devices. There's a load balancer. Here on the left side, you may not be able to see it very clearly, but you have 2 VMs and 8 cores in total. And in the secondary or the disaster recovery, you only have 1 VM and 4 cores. So this is about half of the processing capability for the failover site. And we should also not forget to test the failover of the high availability configuration and the fault tolerant capabilities of the device, of the cluster, of the site high availability or redundancy as well. So that should be regularly tested so that when the failure actually happens, we actually are confident that the failover will happen successfully. Thank you.